In the previous video, we learned how to do addition. But in this video, we are going to learn how to define functions in a very special way. We are going to investigate recursors. But before we continue, let us define another old friend: multiplication. We start by defining 0 times n as being equal to 0. We then define m plus 1 times n as being equal to m times n plus n. And just like that, we've defined multiplication. But let us get back to the main topic of our video: recursors. A recursor allows us to define functions systematically. Let's take the natural numbers as an example. A function from the natural numbers to some other type effectively picks out a sequence of terms in said type. It follows that the recursive for natural numbers is an inhabitant of the following function type. First, we pick an output type. Let's call it x. Then we pick a term in x to which the number 0 is mapped. This will be the first term in our sequence. Next, we construct a function that, given some number and its corresponding term in x, it returns the next term in the sequence. Finally, we are left with a function that maps any number in n to a term in x. Okay, so the recursor is a very complicated function, but how exactly does it work? Well, suppose we wanted to construct a function f from n to a. In that case, we can define f to be equal to rec n a0 as. Note that rec n is defined in such a way that f of 0 is equal to a0, the first term in our sequence, and f suc n is defined as as applied to n fn. Let's take a look at an example. Suppose we wanted to define the function factorial. How would we go about that? Well, firstly note that 0 factorial is equal to 1. And secondly, note that n plus 1 factorial is equal to n plus 1 multiplied by n factorial. This allows us to define a0 and as, which in turn allows us to define factorial using the recursor. Type theorists so frequently define functions this way that they have a name for it. They call it pattern matching. We now know how to use recursors in type theory. Thanks for watching.